over to you.
Great. Thank you, Emily. I appreciate that. As you mentioned, I've spent the last 30 years in New Hampshire working on public health issues related to environmental health, and the last 10 years working specifically on weather hazards and climate impacts. And so I'm very grateful to have people like Dr. Mary Stampone out there working hard to generate the earth science information and meteorological information that we can use in our work. You've likely read the webinar summary. You know that Dr. Mary Stampone is an associate professor of geography at the University of New Hampshire, where she also teaches undergraduate courses on weather, climate, and natural hazards. Her research focuses on monitoring and modeling variability in climate and change regional scale. So an emphasis on the Northeast, and with emphasis on hydrological hazards, including drought, flooding, and severe weather. Dr. Stampone also serves as a state climatologist for New Hampshire, providing citizens, educators, researchers like me, weather and climate adaptation information to support management and adaptation activities. She's a co-author of many reports, but specifically the Northeast chapter of the 2018 National Climate Assessment, and now lead author of the most recent State Climate Assessment for New Hampshire. What you may not know is that one of her research interests is the intersection of climate and weather conditions and perceptions of changing climate. And I hope we hear more about that tonight, with an emphasis on how political affiliations often influence opinions and beliefs. In my outreach and teaching about public health and climate, I often use images from her 2013 collaboration with Larry Hamilton that shows how extreme temperatures on a particular day, or even I should say abnormal temperatures, can strongly influence responses on surveys, especially among political independents who are more flexible. And now, being that we're in the political season of New Hampshire with the primaries and such, we may be hearing more about those political affiliations. And today was the first day we had snow in Concord, New Hampshire. So I know people in the central part of the state are feeling a little different. And those patterns of heat and cold, precipitation, especially snow cover, have been changing. So I will now turn it over to Dr. Stampone so she can tell us more about that and show us some of the work she's done. Seems to be an audio problem. She's still muted. There we go.
I left myself muted. It's bound to happen every once in a while. So yeah, so I'll start sharing my screen and get us started. Okay, well, thank you, everyone. Good evening and welcome. So as Matt said, I'm Dr. Mary Stampone. I'm an associate professor of geography at the UNH, and I also serve as the New Hampshire State Climatologist. And so, you know, given what seems to be sort of one record-breaking severe weather event after another, I thought I'd talk today about how extreme weather events are related to climate change and kind of what that's going to mean for the state and the region over the coming decades. One of the things that sort of influenced that perceptions research, 10 years ago now, was the fact that, I would get a lot of calls from the media or other organizations saying, oh, we've had a heat wave. Is this global warming? And have to say, well, we can't, weather is different than climate, and you can't say any one particular weather event is, directly in response to global warming. But we do think that these types of severe weather events are going to increase over time with global warming. And in the decades since, there's been a really exciting contributions from the work of climate scientists in the area of attribution studies that now allows us to see how certain events are related to climate change and what we can actually attribute as additional extremes that are directly related to climate change. So I'll talk a little bit about that today. All right. So to kind of start us off, it is worth, just a reminder of, what we're looking at when we say weather versus climate, and to kind of look at our forecast for Durham, New Hampshire today. We can see here weather as being visualized as what we would consider the instantaneous state of the atmosphere at any given time and place. And the key thing here is that this is over a short period of time. So we can think of weather as, what we experience on a daily basis, and it affects our daily activities, our clothing choices, travel plans, etc. So I know this morning I kind of changed, the time I went to work because I didn't want to drive in the snow. And so I waited a little bit. So I referred to weather in terms of making my plans for the day. But weather, of course, is primarily influenced by local and short-term atmospheric factors, and is constantly changing. Beyond weather, climate, which of course, like weather, describes the state of Earth's atmosphere, but it differs from weather in that it refers to sort of the average and range of atmospheric conditions that are observed over decades or longer. And so we can think of climate as a more stable and generalized description of a location's typical weather, which for my purposes, we usually determine from the statistical sum of observed weather. And so when you see graphs like the one on the right, those are derived from weather observations to get at climate as the average and range of weather. But when it comes to climate change and the science of climate change, we look at climate more in terms of process. And when you think of it as process, Earth's climate is a complex system that is influenced by larger scale factors such as Earth's position in relation to the sun, ocean currents, as well as greenhouse gas concentrations in the atmosphere. And so this image here, this is a NASA animation that shows global warming since the late 1800s as the difference between each year's annual average temperature and the 20th century average. And so these are derived from observations collected around the world, but they show more the distribution of warming and this slow trend of warming over time that is, of course, occurring in response to the additional greenhouse gases that have accumulated in the atmosphere since the Industrial Revolution. And what this also shows, too, is the rapid increase in the warming rate since the 1970s, which occurs especially over the northern polar and mid-latitude regions where we are. And so overall, warming does vary regionally, but if we look at averages over time, the increase in global temperature will then cause at local scales the value and frequency of warm daily temperatures to increase too, because warming is essentially happening as kind of the short-term manifestation of these larger global scale climate system processes. So we can approximate climate or average climate based on weather observations, but these weather observations are really responding to, again, these larger scale balances between how much sunlight we're getting and how much heat we're retaining in the atmosphere. And so to take another look at this here, this image shows average northern hemisphere temperatures. And so the bell curve that we see here represents the distribution of temperatures from the mid-20th century, so 1951 to 1980 base period. And if we take these same observations, but shift them forward in time through the 20th century, we can see that as the climate system warms, the resulting weather patterns warm as well. And within these warmer weather patterns includes an increase in both the value and frequency of hot extremes, while the occurrence of cold extremes decreases. And so again, we can still expect colder weather to happen in an overall warmer world. In general, as climate shifts toward a warmer baseline, right, we're seeing fewer cold extremes, an overall warmer winter season with more heat extremes occurring during the warm season. And it's worth noting that a warmer Earth will also influence the intensity and patterns of weather systems because warmer air can evaporate more water from the surface. And so studies indicate that for every 1 degree Fahrenheit of warming, the air can hold an extra 4% of moisture. And so if we look here at 30-year average precipitation across the United States, we can see the impact of warming on precipitation patterns. So of course, here we can see the Dust Bowl drought of the 1930s. But as we move on into the 70s, where warming really accelerates, we can see that with the US already warming about 2.6 degrees of Fahrenheit since 1970, our atmosphere now can hold on average about 10% more water than it could 100 years ago. So why do we care about that? Well, this water is coming from the surface. And so if you have an area where you have a lot of water from the surface, you're going to pull that water up, hold it into the atmosphere, increasing the amount of water that can rain out of the atmosphere during storm events. On the other side, if you don't have a lot of water at the surface, it's going to increase the amount of water taken. And if that water is not there, it will increase dryness, leading to an increase in potential for drought. So warming, in addition to creating more extreme warm temperatures, we're also seeing an increase in the extremes on both sides of the precipitation spectrum. You have wetter areas are going to get wetter, and drier areas are going to get drier. So kind of zoning in here on weather and health, we can see that, of course, the increase in the intensity of heat and precipitation extremes obviously poses a direct threat for more severe and hazardous weather worldwide. And here in the US, extreme heat and flooding already account for the greatest number of weather-related hazards or weather-related fatalities. Heat waves are especially dangerous in urban areas, and prolonged exposure to high temperatures can cause heat-related illness and death. And resulting from heavy rainfall, flooding is one of the most common weather-related hazards in the US. And when it comes to flooding, there's the direct health risks associated with the event, along with indirect risks associated with damages to critical infrastructure, contaminated water supplies, as well as community displacements. And global warming has already increased the risks associated with extreme weather events, and greater warming will result in an even greater risk over the coming decades. And so this image is what the IPCC refers to as a burning embers plot, which is a graphical tool used to convey risk associated with extreme weather events within the context of climate change. And so the term burning embers represents the increasing level of risk associated with different climate-related outcomes, or RFCs, which stands for reasons for concern. And the color coding resembles the intensity of the risk, with the colors ranging from white indicating lower risk to warmer colors like yellow, orange, and red indicating increasing risk level with greater global warming. So focusing here on RFC2, this shows the level of risk associated with extreme weather events specifically. And showing where we are right now, we can already see that we're at a moderate risk for current levels of global warming, which is about 0.8 degrees Celsius above pre-industrial levels. Now, if we continue to warm, which we likely will, getting us to the Paris Climate Agreement level of 1.5 degrees Celsius, We're still going to see increased risk from specifically extreme heat as well as precipitation. So those two big ones, heat and heavier rainfall events, those risks are going to increase. Now, further warming beyond 1.5 degrees increases the risk of injury and economic disruption due to extreme weather even further, to the point where we're going to push the limits of our ability to adapt. So here in the Northeast, which of course includes New Hampshire, the region, as well as our state, is already warming faster than the US as a whole. And the seasonal differences are decreasing in response to a winter warming rate that is 3 times faster than summer. And so focusing here on New Hampshire, I'm going to illustrate kind of that difference in the warming rates between lower emissions scenario that is consistent with the emission reduction pledges in place so far, compared to the worst case scenario of global warming resulting from no mitigation or limited mitigation activities. And so already focusing on the black line, the thick black line represents observations, and New Hampshire's annual average maximum temperature has already increased by about 3 degrees Fahrenheit since the late 1800s, which is when records began. And we can expect that temperatures will continue to rise over the next 2 decades. But if we actually follow through with the greenhouse gas reduction targets agreed on in the last Conference of Parties summit, stabilization of atmospheric greenhouse gas concentrations will cause average temperatures globally, as well as here in New Hampshire, to level off by mid-century. And so that's what we're seeing with the blue line. But adding on the worst case scenario of higher emissions, we can see that the warming rate of the next few decades accelerates to nearly 4 degrees Fahrenheit of additional warming by the end of the century. And so considering that the risk to extreme weather events increases with increased global warming, we can see that the benefits of emissions reductions by mid-century in terms of reducing the rate, stabilizing atmospheric concentrations, and allowing our adaptive capacity to address the risks that we know we are already going to see, the risks that we can't eliminate. And so this image is just a summary of the median risk ratings for a variety of weather and climate hazards here in New Hampshire. And of course, the risks for heavy precipitation, which of course leads to flooding, heat, and then flooding itself, all rank high across the state. And our region, not just New Hampshire, but the Northeast region as a whole, is especially vulnerable to severe weather like heavy precipitation and extreme temperature, because much of our infrastructure, our transportation system, as well as power grid, these weren't designed for even today's temperature and precipitation patterns, let alone those that are projected for the future. And so, again, we can't eliminate risks for severe weather. We still have time to reduce the risks if we reduce emissions over the next several decades. And so the next couple of slides, I'm going to kind of illustrate what types of risks we can expect for these weather hazards that we know have direct impacts on health. And these are all from the more recent statewide climate assessment. So you can access these if you would like to take a closer look at them. But I just want to kind of highlight some of the ones that I think are most relevant to assessing health risks in a warming world here, specific to New England and New Hampshire. And so I'm starting with precipitation because it is this enhanced heavy precipitation events that really poses the greatest threat across the region here. And this is due to, again, that increased evaporative capacity of the atmosphere as temperatures continue to rise. And with more water going up into the atmosphere, that is going to increase not only total annual precipitation, which is expected to increase about 8 inches, or has increased by about 8 inches statewide since 1895, but is also going to increase total precipitation going forward, but not distributed evenly, right? But it will occur in more extreme events. And so if we look at projections, we can see that compared to today, we expect more precipitation to shift toward the cold season, so that winter to spring season. This is, of course, the season where we also have snow, and with a warming winter, we can expect more rain on snow events, leading to complications associated with snow melt and flooding. And conversely, in summer, we can expect very little change in precipitation. And so we're going to kind of see a tale of two seasons here, with greater risk for heavy precipitation and flooding occurring during the winter months, with kind of separated from what's happening in the summer, where we're going to have warming temperatures without a similar increase in precipitation to offset the evaporation or the evaporative capacity in the summer, which is going to then increase our risk for drought in the summer. So greater risk for flooding in the winter, and then we see an increased risk for drought in the summer, again illustrating these the impact of warming on the both ends of the precipitation extreme. And so now I just want to take a couple of minutes to look at some of these extreme events across the state and look at the difference between a mitigation projections for extreme weather versus the higher emission projections for extreme weather. And you can think about, our ability to adapt to these changes as they come over the coming decades. So here we're going to show model projections for lower and higher emission scenarios. So the low emission scenarios in the blue, higher emission scenarios in the red for mid-century. So this is by 2050. All right, and so we're going to look at extreme precipitation, which is defined as 1 or more inches of rain in 24 hours, or more than 4 inches of rain in 2 or more days, both of which are expected to increase across the state. So here, for select cities here across the state that were highlighted in the climate assessment, we can see that the frequency of daily events over 1 inch is going to increase significantly for inland and northern areas across the state, with a near ranging anywhere from 30% or close to 30% under lower emissions pathways, up to 50% increase for higher emission pathways. And going closer to the seacoast, all right, we can see that these larger storm events, so these are represented as number of events per decade, right? We can see that under higher emissions, the occurrence of these events, so we can think of these as some of those like nor'easter heavy precipitation events that we get during the cold season. We can see a near doubling of these events across the seacoast region just by mid-century for the higher emissions scenario. Now turning to temperature, course, as our climate warms, the threat posed by extreme heat increases as the frequency of hot temperature extreme increases. And so heat extremes disproportionately affect elderly, people with chronic illnesses, outdoor workers, and low income and marginalized communities overall. And then, of course, geographically, heat extremes are greatest within urban areas, but rural residents without air conditioning are also at risk for during the hottest days and nights of the year. And so taking a look at our exposure to heat by mid-century, we can see that, or we can expect the number of days per year above 90 to double by 2050. But under the high emissions scenario, we can expect upwards of 10 more days above 90 Fahrenheit compared to lower emissions. So again, we need to be prepared for an increase in extreme heat, especially the occurrence of heat waves. But that increase is going to be that much more under the higher emissions scenario. And of course, one of the most effective ways to beat the heat is, of course, to go into an indoor cooling space. And so with this extreme heat, we are going to see an increase in the amount of energy required to cool indoor spaces. So that's shown here as a cooling degree day. This is a metric used by utility companies to approximate how much energy is needed to cool indoor temperatures during the summer months. And again, in some places under the higher emissions scenario, we can see a near doubling in the amount of energy needed to cool indoor spaces in response to the increase in extreme heat during the summer months. Now, while warming is projected for all seasons, the greatest warming rate is going to occur during winter, particularly at night when the lowest temperatures of the year occur. And so overall, we can expect fewer nights below freezing, which will result in less snow cover and fewer days with snow on the ground. This has incredibly important ecosystem impacts of our northern forest ecosystems that have adapted to having these very cold and snow-covered winter seasons. And then along with the warming of winter, the winter season is going to get shorter, which will increase the length of the growing season, which is defined here as the number of frost-free days, or days where minimum temperatures exceed 28 Fahrenheit. This is a common metric used to define the growing season, and we can expect, on average, a 1 month increase in the length of our growing season as our winter season contracts. And so to kind of summarize this is an image from the National Climate Assessment's special report on health. And it just kind of shows sort of the cumulative effects of climate change, the influence on extreme weather, and how that can impact both social and environmental systems. And so looking at social systems, we can expect disruptions due to severe weather to occur to our food supplies, damages to infrastructure, impacts on communities, as well as local economies. And then all of this is exacerbated by vulnerability, with disproportionate impacts impacting vulnerable populations, including children, older adults, communities of color, low income, and persons with disabilities and chronic medical conditions. And then add on to that the impacts on ecosystems. Ecosystems can influence health, with especially when we're looking at that increase in the length of the growing season. Will increase allergies. We can expect an increase in vector-borne diseases, transmission of diseases through invasive species, decreased water quality, as well as sort of longer or larger scale impacts from disasters in other places, as we saw with the air quality associated with the wildfires that occurred all the way up in northern Canada, decreased our quality of air here. So it's not just what's happening here in New England, but the impacts, ecosystem impacts of severe weather elsewhere can impact us as well. And so while all of this, kind of putting this all together sounds very scary and dire, it is worth remembering that there is still time, and through a combination of mitigation and adaptation, we have the tools to address these challenges, and specifically address our challenges to increasing risks of severe weather. And so we're already employing a lot of adaptation measures to deal with extreme heat and heavy precipitation. But it is worth noting that adaptation alone isn't going to be enough, because again, we expect these risks to increase with increasing global warming. So adaptation needs to be paired with greater mitigation to reduce the risk overall, and allowing the adaptation measures and the resilience of our systems to address the needs of the communities that are being impacted by severe weather and climate extremes. And so I will leave that there. If you want me to put up the slide here on health, we can kind of leave that there, or I can take down my slides and we can have a chat.
Great. Thank you, Dr. Stampone. We did get a couple of questions in to the chat, and we'll get to those in a second, but I want to thank you for that clear review and for those really interesting dynamic images you had there. It's really helpful to see changes over time, so I appreciate those. And my first thought or feeling is always, I want to take those and use those in my next presentation. So thank you for that.
I will say they're all publicly available, and I can provide a list and links to those for those who are interested.
Thank you. Great. Well, that was a great overview, and we've got a lot of time for questions and chat and discussion here. The first question I'll roll up to is comes from Mike Dullen, and it says, how does the model align with prior climate events and climate data? So looking at what you have here, I guess they want to know more about how you compare it to the past.
I mean, it was in relation to the extreme weather events that you had projected, or you have the future weather event forecasting for the next 30-year segments. But how does that align with prior extreme weather event modeling that you have the opportunity to kind of overlay, presumably used in the model itself?
Yeah, so our projections for things like increased heat and increased heavy precipitation events, there is high confidence in those model outlooks, and they are consistent with previous models. And so what each iteration of models is allowing us to do is to kind of get, just kind of refine our estimates. And so some of the measures that have consistently performed with high confidence in the models are the heat and the precipitation. Unfortunately, our ability to resolve the issue of drought is still, there's still quite a bit of uncertainty, which is why I didn't show any kind of, specific numbers associated with drought. We do think that we are at an increased risk for more frequent short-term drought during those summer months, but the uncertainty is still there, as opposed to the confidence we have in those values for heat and heavy precipitation.
And Mike had another question about what models are used to calculate economic impacts in those burning ember plots. So if you have any background information on that.
I can. I mean, I can't necessarily speak to that in terms of in great detail, given my expertise, which is in the climate part. But the IPCC uses a variety of what they call socioeconomic pathways leading to cumulative atmospheric greenhouse gas concentrations. And so the models we used in the climate assessment that we did for the state were based on the CMIP-5 models that were used in the last IPCC report. This new sixth assessment that came out, and the fifth national climate assessment that is coming out in a couple of weeks are all going to use CMIP-6. So it's one generation above what I showed here. Hopefully our next assessment will be able to make use for some of those. But the reason I went through all that is, so the ones I showed are based on the IPCC's fifth report that used representative concentration pathways. So they modeled economic activity leading to a certain number of emissions. Now, the newer models account for the human piece with the shared socioeconomic pathways, which are a little bit different, and they are more kind of story-based. So they're more sophisticated than just approximating how or what greenhouse gas concentrations are going to be. They account for not only economic activity, but inequality. Now, the details on how they do it are beyond me. But again, with each iteration of models, the ability to approximate the human part, the societal contributions to this becomes more sophisticated. So you have the shared socioeconomic pathways now account for kind of different converging economic factors that again account for inequality, which I think is a improvement on what those representative concentration pathways I showed account for.
Yes, predicting human behavior, especially in the economic context, is always challenging.
I tell my
know.
students, and when they say, "Oh, science is so hard," I'm like, "Are you kidding me? You're a humanities major. That's hard. People are hard.
It is.
Science is physics.
That's why you team up with sociologists to do some of your work. I know that.
Exactly.
There is another question from Mary Woodward, and she's welcome to unmute, or I can read it from here. They're asking us something about James Hansen's latest projections, and she says, is it too early to comment on the possible implications for New Hampshire's climate change timeline if James Hansen's latest projection is correct?
Yeah, so I'm not sure exactly what he's basing that on. So I'd have to take a closer look at what he specifically says. But you know, the implications from the sixth IPCC report, you know, I kind of feel like a broken record, but really the implications are what we've known for decades here in the Northeast. We're going to get heavier rain events. We're going to see more high heat days, also extending further into the later part of the summer season. And so more of them, more resources required for cooling, while an overall, you know, just continued warming, rapid warming of our winters.
All right. Well, if Mary Woodward has a follow-up to that around specific, if James Hansen's projections are saying there's going to be, you know, lesser or more impact, maybe she can add that into the to the chat there.
So I'm here.
Great.
Hi. Yes. So his latest paper that came out, I think within the past couple or 3 weeks, I think in one of the Oxford journals, projects that we're blowing past all the models, and that we're going to have we're going to blow past. We're going to be at 2 degrees by 2050. And some of the scientists are debating this, and I mean, I assume that that just means that everything you're talking about will happen sooner.
Yeah, and so okay, no, that makes more sense now. Yeah. So overall, yeah, we one of the things with all of these models is that we're still, they're all, agreeing with each other, we're getting warmer. It's just with each iteration, it gets worse. And as we refine the models more and more and we get more details, it gets worse. And so the values I showed in the blue, those values are pretty consistent with what would happen in response if all of the pledges to reduce greenhouse gas emissions come true by 2050. That is a realistic representation of the type of extreme weather we can expect here. And it's worth noting that that projection is above 2 degrees Celsius of warming by 2050. So that still not only overshoots Paris, which is less and less likely, but it overshoots that 2 degrees Celsius of warming that, dates back to the 1970s when economists were saying, our ability of our socioeconomic systems to adapt to the changes that 2 degrees Celsius of warming brings is, that's kind of the limits. And beyond that, things are going to get rough. So it, there are a lot of folks out there who don't have a lot of hope that we'll be able to stay at that 2 degrees Celsius of warming. But, so we shouldn't be hopeless though, because even is getting as close as we can is still better than just letting it run away.
Yeah, it's about degrees of change, and we know that 1.5 to 2 degrees of change is a significant difference, but the goal is to kind of shoot for incremental change and reducing those because we don't want additional impacts.
Yeah.
Well, and on the positive side, some of the lists do say that New Hampshire is one of the best states to be in, given how the climate is changing. Even though we're looking at a lot of change ourselves, it still is supposed to fare well, relatively speaking.
Yeah. And again, it's about being able to adapt. I mean, we know there's going to be change. The key is to limit the change to what we can adapt to. And being here in New England, we're already used to a lot of weather extremes. And extreme weather is nothing new. That's not climate change. That's the way things are. It's just the frequency, intensity of the extremes increase. And so being able to adapt and respond to those is key. I'm not going to scare you with the whole in-migration for our good climate.
All right. Well, we'll move on. We just got a message from Reb McKenzie. Do you want to unmute and talk about it yourself, or do you want me to read it?
Matt, go ahead and read it. Thanks.
The question says, do you agree with other reports I've heard that New Hampshire lags behind New England states in preparing for more extreme weather? If so, what are you suggesting to help with adaptation and mitigation that will be most effective?
So when it comes to adaptation, I think we're actually doing as well as as we can. Adaptation is expensive. Everyone is dealing with limited funds. But our state has invested quite a bit in adaptation, especially around heavy precipitation. There's been a lot of infrastructure work across the state looking to improve roads and increase culverts, improve our stormwater systems. That has been the impact of heavy precipitation, even beyond flooding, just the ability of our stormwater systems to just move away. Regular thunderstorm rain was limited. And so there's that or those limitations of our infrastructure have been known for decades, and so the state has been investing heavily in that. We know we need to invest in heat mitigation. And I know, Matt, you can probably speak a lot to this, but the state has been involved in that. There are some barriers and cost barriers to heat, given the age of our infrastructure, the general lack of air conditioning already. That's kind of a concern. But overall, our state is really looking into adaptation. Where we lag behind across New England is in mitigation. And I like to think of mitigation as adaptation, because the more we mitigate, the less we're going to have to adapt to. And so, one of the things that I kind of stress is that adaptation alone isn't going to be enough. We also need to mitigate.
Yeah, I would agree. We've done a lot of good work in the state around trying to help people adapt to extremes in weather. And everybody doesn't always call it climate adaptation. They may just say this is emergency preparedness work. This is, as you said, dealing with our infrastructure. We had a huge infrastructure bill go through Congress a few years ago, which is being able to now coming into the state. And FEMA is also now saying that, they'll fund you to rebuild better, not to rebuild back to the same culvert size or the same thing you had before. So that's been a good improvement too.
Yeah, and I will say the whole purpose of the state climate assessment that we did and I showed here was to inform DES in their adaptation planning. They've been planning for a 15% increase in precipitation for years. And so they're working on this as we speak.
And when it comes to heat adaptations, we know from a public health perspective, the most at-risk groups are, basically between 15 and 35 males who tend to end up in the ER or be impacted by that. And that's because they're less adaptable. They're also taking on more high-risk occupations, things like that, which expose them to the heat. Then the other kind of curve is men and women over the age of 65 and 70, and they're just become less adapted with age. Their thermostats basically go off, and they continue to do the same things that they had done before, which is mowing the lawn and doing other activities in extreme temperatures, which used to be fine for them, and they're just not as adapted. So those are the two groups we're trying to work on. Good news is that over the last 50 years in the United States, heat-related illnesses and deaths have been going down because people have more conditioning, because they have better training, because there's more worksite controls. So even as we warm, we can expect to see improvements in public health. So that's good news for people.
Yeah, and right there, I mean, that's a great example of the fact we have the tools.
Yes,
to
we can do
it.
I tell young people we've taken on big problems before and we've solved them. We will do it again. Whether it's air pollution, water pollution, ozone layer, we have taken on a lot of big things, and we'll continue to do that. One question I had for you, Mary, is wondering when you do your estimates for the New Hampshire climate assessment, the most recent one you did, do you look at higher ambient temperatures, or do you try to look at heat index that might reflect more of how humans are stressed?
Yeah, these are accounting for ambient temperatures. We don't have we can't resolve humidity well enough in these
Right.
models to do the projections for the heat index and the heat stress values. There are some good sources for heat stress observations. So with the data, we can do that. But kind of going back to the model limitations, the humidity is more difficult to resolve. But we also know, because the air can have more water, that humidity values are increasing as well. It's just not something we're able to resolve quite yet with the models. But we're hoping to get there.
Good. Okay. Semmer has a number of comments here. I don't know if I see a question within them yet, Semmer, but you're welcome to unmute and ask a question if you'd like.
Sure, and they are more comments, so I would definitely yield the floor if people have more questions. So if anyone else has a hand up, I will gladly wait.
No, no one does. And because you're a well-known epidemiologist at UNH and across the state, we'd like to hear your perspective on health
Oh, well,
impacts.
thank you. And first of all, Mary, thank you. This has been great. And I have a couple of my students in my MPH class here. So it's just great to hear this summary. And I guess my comments, which are, we can just discuss them or people can rebut them. One of the things that I feel is that our hospitals, I guess I'll kind of point a little bit of a finger, are not quite taking on mitigation efforts as much as they are in states like Massachusetts, for example, and really just kind of committing to sustainability and climate change mitigation when we know that the healthcare industry contributes 8 to 10% of our greenhouse gas emissions. So I would like to see that at least move forward a little bit in that sector and maybe partnering a little bit more closely with public health. Maybe that's an opportunity for the future. And the other comment I had was I have learned partly from the group that I've been working with across the state that people taking certain medications, in addition to the groups that Matt, you mentioned, I wasn't even aware of all these groups, but a lot of people who take certain medications for mental health conditions, sort of bipolar, anti-seizure, all kinds of other medications, heat, even a relatively small increase in temperature can greatly affect them because their ability to thermoregulate is affected by their medication. And some persons who use substances also, of course, we think of homeless people, that would be another group, but many people who are being treated for a condition might find that their medication interferes with their ability to regulate their body temperature.
And these are all great points too, because that also goes to the adaptive capacity. We have kind of a baseline adaptive capacity, but we need to also recognize, again, those vulnerable groups within our communities,
right,
that they have a lower adaptive capacity. So not everybody is equal in this system.
Yep.
And so, we have to consider, the impacts that these impacts are not going to be evenly distributed across society.
Very true.
Those medications are important, and that's definitely for people on this call, clinicians and healthcare workers, they should be looking at what those are, especially the day or when they're predicting a heat wave. They can begin looking at that and assessing with their patients. What we haven't done yet is integrated into the history to kind of link up weather conditions outdoors with what clinicians are recommending day by day. So that's a future work we can do. We've got a lot of work to do on record keeping, but that's one more. But your comment that people who use substances, whether that's alcohol or otherwise, they have cognitive impairment, and that really makes it hard for them. And we have known in public health for decades that one of the strongest associations with any outdoor injury is use of alcohol. So whether that's getting bit by a snake, whether that's getting injured, all-cause injuries, when alcohol consumption goes up, so does the injury rate. And so I would expect it to be the same with heat stress, but I haven't read an article or a research report on that yet.
Yeah, and the one I forgot to mention that I know it's an emerging area of research is just violence, that violent behavior, whether it's domestic violence or violence against a partner, apparently really is correlated, at least with high heat events across the globe. So that's another public health issue.
It is, and whether that they don't know yet whether that is that people become more violent or combative, or is it that people are interacting a lot more? So those people who already have existing problems between them are beginning to meet each other more often. So, we have people going indoors and spreading infectious disease in the winter, and we have people going outdoors with violence and confrontation issues in the summertime. So those are ongoing long-term public health issues we know about, and I'm sure climate change perspective needs to be integrated in there.
Yeah, and it's also worth mentioning too, the work environment. So obviously, outdoor workers are going to have greater exposure. And we also tend to forget about indoor workers. And if you think about this area, a lot of offices are air conditioned. unfortunately mine is not. But there are also, industrial workers. My husband's a brewer, and so he works in a brewery. And, there were times this summer where, I mean, it was well over 115 degrees Fahrenheit inside, inside the warehouses. And so these issues are not just for outdoor workers. And then, of course, the additional costs of putting in air conditioning in these areas might be prohibitive for some people, where they live, or employers. And so there are some of these barriers to that main adaptation piece, which is, indoor cooling, which, of course, running air conditioners contributes to global warming, depending on the energy source. So there are a lot of connections. I had a lot of calls early September when we had that little heat wave. My classroom was 103 degrees Fahrenheit. But we had, canceling practices, canceling football games, outdoor events, and schools are now starting to have to think, wow, we're going to have heat days in addition to snow days. And so in addition to the health risk, there's the productivity, lost economic income, and the, economic impacts of heat kind of across the board. That's just more
All right. Well,
comment.
we have about 2 minutes to go. We've had a great discussion. It's really great to hear people opening up their mics and talking with us and getting feedback. It always makes for a much better interaction. Are there any last questions or any last thing you'd like to say, Mary, to healthcare workers? Anything you've already mentioned a lot of different things, but we'll give you a chance to have the last word.
Yeah, I guess working with people, and again, recognizing that these impacts are not evenly distributed across populations. So you're going to see, differences, and one patient, the capacity of one patient is not necessarily going to be the same as another patient. And and Summer mentioned, mental health. We're also seeing an increase in depression surrounding environmental issues, particularly with young people. And I think it's worth you don't want to be Pollyanna about it, but also do need to point out that, again, we have the tools, we have the ability to address a lot of this, and that mitigation to reduce the biggest impacts is still possible. And so kind of keep that message going forward.
Great. Any new research coming out that you can tell us now that you haven't told anybody else about yet that we should know about?
My current work is actually looking at resilience in rural communities and kind of addressing the housing issues and weather hazards for low-income rural residents across northern New England.
Great. We look forward to seeing that soon. So we'll make sure, keep us in the loop, send something to Emily or to me, and we'll stay in touch. But we want to thank you very much for your presentation tonight and for all the great information.
Thank you. And I'm more than happy to share my slides if that's wanted. So Emily, if you want to connect me, I can share those with you.
Absolutely. Yeah, I will follow up tomorrow with a link to the recording and some links to slides. Thank you so much, Dr. Stampone, for being with us tonight. We really appreciate your time. Thank you, Matt, for your wonderful moderating, and to everyone for your participation and questions. I look forward to seeing you at an event in the future.
Thank you, everyone.
Bye.
Have a good night.